So today's lesson is lesson 9. It's tables of equivalent ratios. Our I can statement is I can understand that a ratio is often used to describe the relationship between the amount of one quantity and the amount of another quantity, as in the cases of mixtures or constant rates. So what we have here is, again, we're working with that ratio. We're comparing one thing to another thing. And we have that word equivalent again. So we're going to have equivalent ratios, meaning 2 to 3 is equivalent to 4 to 6. And if we remember from our last lesson, how we know they're equivalent one way is they have the same value. Remember, a value means that it's a fraction in simplest form. So 2/3, is that the same as 4/6? Well, it is, because I can simplify it to 2/3. So they are equivalent ratios because they have the same value. Alright, so let's begin. So here's our first problem. To make paper mache, the art teacher mixes water and flour. For every 2 cups of water, she needs to mix in 3 cups of flour to make the paste. Find equivalent ratios for the ratio relationship 2 cups of water to 3 cups of flour. Represent the equivalent ratios in the table below. So here I have this is my main focus. It's saying represent the equivalent ratios in the table below. So it's asking me to show, represent means show or write, the equivalent ratios. So I'm not just focusing on 2 to 3, but I'm focusing on all those ratios that represent the same amount. So my first one is easy. It says I have 3 cups of flour, so I need to make sure I put that in the correct column. Here's my flour, 3, and it says for every 2 cups of water. Now, what does that mean? Well, if I have 2 cups of water, that means I have 3 cups flour. If I double it, I'm going to have 4 cups water. How much flour? Well, I have to double my flours too, so I'm going to have 1, 2, 3, 4, 5, 6. I'm doubling it, so I have twice as much. Same thing here. I'm going to add another 2 cups of water. So whenever I add 2 cups of water, so here's my 4 from before, I'm adding 2 cups water. Whenever I add 2 cups water, I have to add 3 cups flour. So now I'm going to have 1, 2, 3, 4, 5, 6. Here's my 6 from before. And I just added these 2, so I have to add another 3 flours. So I get 9 flours. You'll notice there's a pattern. When I add 2, I add 3. So let's add another 2 cups water to 8. Whenever I add 2, I have to add 3 cups flour. So that's 12. Whenever I add 2, I add how many cups of flour? On Socrative, I want you to log in and tell me what goes in that box there. Pause the video and unpause it after you've submitted your answer. So hopefully you got that last problem right. So let's look at this question. What does the ratio mean? Well, my ratio was 2 cups flour is 3, or 2 cups water is 3 cups flour. I'm asking, why is it worded for every 2 cups of water, there are 3 cups of flour? What that means is it suggests we might be doing this action repeatedly. We might be adding 2 cups of water and 3 cups of flour multiple times. Now, why would I be adding it multiple times? Well, if I'm a baker, so if I was thinking this was a baking project, do I just make one batch of cookies and then say that's it? No, if I'm a baker, I'm probably going to do it multiple times. If I look back at this specific example, it's telling me that this art teacher is going to be doing this. Now, one batch might be enough for only 3 kids, so she might have to make multiple batches. So let's go on to this part. Is there an equivalent ratio that uses smaller whole numbers than the ratio 2 to 3? No. If I think of it as its fractional form, 2 over 3, I can't simplify that anymore. So that's my smallest equivalent ratio. Now, what would the next possibilities be if we were using only whole numbers? Well, I know if I double it, I'm going to have 4. Whenever I add 2, I have to add 3 cups flour. Add another 2 cups water. Have to add 3 cups flour to get that 9. 2 cups water. Adding 3 cups flour to that 9 to give me 12. Adding 2 cups water. I have to add 3 to get that mystery number here. I want you to notice, what is the value of all of these? Remember, value is a fraction ratio in simplest form. So it's a fraction simplified. Now look at this value. 2 over 3, that's 2/3. The value of 4 to 6, that's 4/6. And if I simplify it, divide each side by 2, I'm going to get 2/3. 6/9, I can simplify that by 3 to get 2/3. 8/12, I can divide my numerator and denominator by 4, and I get 2/3. And I bet when I did this one, I would have gotten 2/3 as well. Now, what do you notice about them? What do you notice about all of these values? You should notice that they're equivalent. So, since we're making a ratio table of equivalent ratios, we should then get the same value. If you remember from our last lesson, if our ratios have the same value, then what does that mean? It means that they are equivalent ratios. Then they were equivalent. So yeah, if I look down here, is that value what we expected? Should the value of all these ratios be equal to each other? Our answer is yeah, they should, because equivalent ratios have that same value. So let's watch this short little video on ratio
Greetings,
tables.
mathematicians. In this lesson, you will learn how to make tables with equivalent ratios. You'll be using the strategy of first understanding the ratio, and then using that understanding to write equivalent ratios in a table. Let's go over what you already know. You already know what equivalent ratios are. For example, if I write 1 to 2, you know that an equivalent ratio will be 2 to 4 or 4 to 8. And the reason that these ratios are equivalent to each other is because there's the same unit increase from the left side to the right side. So for every 1 unit here, I'll have 2 units here, and that's a 1/2 relationship. And for every 2 units here, I'll have 4 units here, which is again another 1/2 relationship. And the same goes for 4 to 8. So equivalent ratio tables are just a way of organizing ratios. So first we'll be using our strategy of understanding the ratio. So here with 4 to 12, we see that for every 4 units here, I'll have 12 units here. So I can write that as 4 to 12. And to add to my understanding, I know that that's a 1/3 relationship, because I can reduce this ratio to 1/3. Now let's use this understanding to write equivalent ratios in a table. Well, I already wrote one up here, so I know that an equivalent ratio is 1 to 3. Another equivalent ratio would be 2 to 6. Let's work on another example that uses units of feet and inches. Let's first understand our ratio. We know that for every 1 foot, there's 12 inches can be represented as 1 to 12, or as 1 over 12. Now let's use this understanding to complete this table. So if I have 2 feet, I'm going to have 24 inches. If I have 3 feet, I'm going to have 36 inches. And I have 4 feet. I'm going to have 48 inches. All these ratios are equivalent to each other. Let's go over our final example. For every 1 yard, there are 3 feet. So let's understand this ratio. I can write it as a 1 to 3 relationship, or I could write it as 1 over 3. Now let's fill out this ratio table. So if I have 2 yards, how many feet will I have? I'll have 6 feet. If I have 3 yards, I have 9 feet. And if I have 4 yards, I'll have 12 feet. And all of these ratios are equivalent to each other. In this lesson, you learned how to make tables with equivalent ratios by first understanding the ratio and then using that ratio to fill out a table.
Alright, so let's continue with this problem. Leon has a new job designing websites. He is paid at a rate of $700 for every 3 pages of web content that he builds. The created ratio table shows the total amount of money Leon has earned in ratio to the number of pages he has built. So what this is saying is Leon has a job. When he builds 3 websites, he's paid $700. So that's going to be our ratio. Our ratio is going to be 3 to 700. So what we need to do is on this table, we have to figure out how much money he's going to make depending on the number of web pages he builds. Our first thing we need to do though is that we need to figure out our labels. Well, one label is going to be the total amount of money that he earns, so his total money earned. The other one is going to be his number of web pages he builds. So my ratio is that web pages to his total money. Well, the first one, that's going to be easy. He builds 3 and 700. If I write that as a fraction, 3 over 700, I can't simplify it anymore. So that's going to be my smallest ratio that I'm going to start with. So let's go with the next one. If he builds another 3, how much money will he make? Well, he's going to make this much. So he's going to have 700 plus 700. If he builds another 3 websites for somebody, he's going to get another $700. So we add 700 to 1400 for 21. Now, let's switch it. He just earned $700 more. How many websites pages do you have to build? Well, whenever he increases by 700, he made 3 more web pages. So I'm going to add 3 to that 9. And my pattern is going to go on. When he makes 3 more, he makes $700 more. 3 more web pages for 18, $700. 3 more web pages, $700. Okay, now think of this one. He just made $700 more dollars. Answer on Socrative. How many web pages did he have to make to earn that 5,600? Pause the video, start it back up whenever you're ready. Okay, now let's focus on this one. Leon is saving up to purchase a new supercomputer for gaming that costs $4,200. It's a really expensive computer. How many web pages will Leon need to build before he can pay for it? Well, I'm looking at this. That's his total money that he's earned. So I'm going to be focusing on this line in my table, this row. So I'm going to look for 4,200, and look, I see it right here. And so if I check that, how many web pages did he have to build to earn that much? Well, I see that he had to build 18 web pages. So for him to make 4,200, he had to make 18 web pages. It's a pretty nice paying job right there, Leon. Okay, let's continue to our next one. So here's another table. Spraying plants with cornmeal juice is a natural way to prevent fungal growth on the plants. If you'll notice, this word fungal, it's my base word. It's actually related to the word fungus. So fungus is that pretty nasty stuff that grows on food that we don't want to eat. It's kind of like a parasite. So what we do is we don't want fungus growing on our plants, so we spray it with this cornmeal juice. It is made by soaking cornmeal in water, using 2 cups of cornmeal for every 9 gallons of water. Complete the ratio table below to answer the questions that follow on our next slide. So I have this question, cups of cornmeal versus gallons of water. Well, it's telling me right here when I look, 2 cups of cornmeal for every 9 gallons of water. So let's check. Is that my smallest ratio? 2 cups of cornmeal for 9 gallons of water? Yeah, I can't simplify this anymore, so that's going to be my smallest equivalent ratio. So my first ratio is going to be 2, and then for every 2 cups of cornmeal, there's 9 gallons of water. If I add 2 cups of cornmeal, so here's my 2, and I'm adding 2 more, I have to add 9 gallons of water. So I've started with 2 cups for 9 gallons. 2, 4, 5, 6, 7, 8, 9. 2 cups cornmeal, 9 gallons of water. Then I've added another 2 cups cornmeal, so I need to add 9 more gallons of water. 1, 2, 3, 4, 5, 6, 7, 8, 9. That makes a total of 19. So 4 cups of cornmeal would need 19 gallons of water. If I add 2 more cups of cornmeal for 6, I need to add 9 more gallons of water for 27. If I add 9 gallons of water, to keep my ratio the same, I have to add 2 cups of cornmeal. Now, how many cups of cornmeal would I need if I have 45 gallons of water? Answer this question on Socrative. When pause it if you need to, then continue on with the lesson. Alright, how many cups of cornmeal should there be if I have 45 gallons of water? Well, I look down here. There's my gallons of water. If I have 45, how many cups of cornmeal? Well, I look over here and I see the associated ratio number is 10. So I would need 10 cups of cornmeal if I have 45 gallons of water. Paul, for our next question, he only has 8 cups of cornmeal. How many gallons of water should he add if he wants to make as much cornmeal juice as he can? So I'm going to look, where's my cups of cornmeal that equals 8? It's right here. And now my question is saying, how much gallons of water should he add if he wants that cornmeal juice? Answer that question on Socrative. When you're done, go to the next page. When you're done, unpause the video. So now let's look at this question. What can you say about the values of all the ratios in these tables? Well, I'll notice the value of 2/9 is 2/9. 4/18, I can divide my numerator and denominator by 2 to get 2/9. 6/27, I can divide that by 3, my numerator and denominator, and I will get 2/9. 8/36, I can divide my numerator and denominator by 4, and look, at 2/9 again. And 10/45, what number do you think I'd divide by? 5 to simplify, and I get that 2/9. So look, once again, what do you notice about all of these values? All those values are the same. If ratios have equivalent values, then that means that the ratios themselves are equivalent. So 2/9 is equivalent to 4/18 because they have that same value. 2/9 is equivalent to 10/45 because they have that same value as well. If our ratios have the same value, then the ratios are equivalent. Alright, here's our next problem. James is setting up a fish tank. He's buying a breed, so a breed is a type, so he's buying a breed of goldfish that typically grows to be 12 inches long. It is recommended that there be 1 gallon of water for every inch of fish length in the tank. What is the recommended ratio of gallons of water per fully grown fish tank? So what I need to do is I need to first notice saying fully grown goldfish. How big is a fully grown goldfish? Well, that's that 12 inches. For every 12 inches I need 1 gallon of water. So it's asking us now to complete the ratio table. Well, my ratio is going to be 1 goldfish. And how many gallons of water is that? Well, let's start here. 1 goldfish. And actually, I think we're going to do our number of goldfish first. 2 goldfish. I'm just adding 1 each time. 3 goldfish. 4 goldfish. 5 goldfish. Now I need to figure out my number of gallons. Well, one goldfish is 12 inches long. If it's 12 inches long, how many gallons would that be? Well, it needs 1 gallon per inch. So if it's 12 inches long, that means it needs 12 gallons. If I have 2 goldfish, that means there's 24 inches in there. So I need 24 gallons. 3 goldfish, that's 3 times 12, my inches for 36. 4 goldfish, that's 4 goldfish that are how big? 12 inches each. So that's going to be 4 times 12, which gives me that 48. And so, Socrative, I want you to answer this question. Pause the video if you need to, then unpause it and continue on to the next slide. Alright, I hope you did well on that. So let's look at this question. I want you now on Socrative to answer this question. What size tank in gallons is needed for James to have 5 fully grown goldfish? So I'm looking for how many goldfish I have. There's 5. How many gallons of water do I need? Answer that question on Socrative, then continue on with the lesson. How many fully grown goldfish can go in a 40-gallon tank? Well, this one's a little tricky. It's telling me how big is my tank? It's 40 gallons. So what I want to do is I want to look and see, do I see 40 gallons anywhere on here? I don't. The closest I see is a 36 and a 48. So I'm kind of stuck. What do you think I should do? Well, let's check. 40 I know is going to be somewhere right in between here. So I know it's going to be either 3 or 4, since 40 is right in between 36 and 48. Does it make sense for me to have 3.5 goldfish? Because that's right in the middle. Actually doesn't. What are you going to do? Cut the goldfish in half and just let half of it swim in there? That's not what I'm going to do. So what I need to do is I need to figure out something different. If I have 4 goldfish, the minimum amount of water I need is 48. They're not going to survive if I have less than that. So if I say there's 4 goldfish for 40 gallons of water, that's not at the minimum requirement. So my goldfish would die. So what I have to do is I have to go to my number that's right above. 3. If I have 3 goldfish, the minimum amount of water they need is 36. Now, I actually have slightly more than 36. Do you think my goldfish are going to be okay if I have more water? Yeah, they'll be fine. So my answer is 3 fully grown goldfish can go in that 40-gallon tank. If I try to squeeze 4 in, my goldfish are going to die because that number is not at my minimum requirement. So it's not 4. 4 has to have at least 48. So let's look again at this last question down here. What can you say about the values of the ratios in this table? All my values are equivalent. This is going to be 1/12. 2/24 is its value, but I need to simplify it by the top and the bottom by 2. 3/36, again, when I simplify it, I divide my numerator and denominator by 3, get 1/12. 4/48 is going to simplify to 1/12 as well. And 5/60, when I divide my numerator and denominator by 5, I'm going to get 1/12 also. So here I remember my values of ratios. If they're the same, that means my ratios are equivalent. Alright, so we're almost done with our lesson. What I want you to think is, when you're creating a ratio table, what does each pair of values represent? Well, each pair of value represents a ratio that is equivalent to all the other ratios in the table. And it describes the ratio relationship of those two quantities. So an easier way to think of it is when I have this problem here, I have these two values, and they're describing a relationship to all my other ratios. What's that relationship? It's that they're all equivalent. And why are they equivalent? It's because they have that same value. So this is the key thing I want you to remember taking away today. A ratio table is a table of pairs of numbers. Pairs meaning 2. It's a table of pairs of numbers that form equivalent ratios. And how do we know that they are equivalent ratios? They have the same value. Please remember that. If ratios have the same value, they are equivalent. Remember that value is a fraction simplified form. Okay, this is going to be your exit ticket. I'm going to walk you through part of it. A father and his young toddler are walking along the sidewalk. For every 3 steps the father takes, the son takes 5 steps just to keep up. What is the ratio of the number of steps the father takes to the number of steps the son takes? Add labels to the columns of the table. Place the ratio into the first row of data, Add equivalent ratios to build the table. So what I'm going to do is I need to focus on what am I comparing? Ratio compares 2 things. I'm comparing the steps the father takes to the steps the son takes. So my ratio is going to be father steps to son steps. So father to son. On Socrative, your question you're going to answer is you're going to tell me what ratio goes in here. After you've answered that question, you're going to tell me what number would go in here for the number of father steps. Alright, after you've done that, your assignment is as follows. You're going to go on to Khan Academy. On Khan Academy, you're going to complete 2 lessons. 2 lessons. After you've done those 2 lessons, you may go to math games. That includes Ratio Rumble. Or you may go to typing games. Either one is okay. You may also, if you want to, review math videos as well, if you owe me a makeup test. So you may also review math videos. Any of those options are fine after you've answered your Socrative questions and you have done that Khan Academy. Alright, good luck.